Imagine being 200,000 miles away from Earth. At this distance, there are no backups, no supply drops, and a physical rescue is impossible. By April of 1970, NASA had already successfully landed on the Moon twice. Public and institutional confidence had grown so high that lunar missions were being viewed as routine operations. Commander Jim Lovell and his crew boarded Apollo 13 with the straightforward objective of reaching the lunar highlands to conduct surface research. But treating spaceflight as routine ignores the lethal reality of the vacuum. That oversight lasted until the exact moment the environment became unforgiving. 2 days into the mission, a standard procedure triggered a short circuit. Deep inside the spacecraft service module, an oxygen tank violently exploded. This diagram of the service module shows the immediate consequence. Once the tank ruptured, the ship began venting its oxygen and electrical power into space. At mission control, telemetry monitors suddenly bottomed out. They heard a bang over the comms, followed by Lovell's report. "Houston, we've had a problem." The original mission objectives had vanished. Every effort on Earth was now redirected toward a single engineering calculation: how to keep 3 men alive in a failing ship. To survive, the crew had to power down the dying command module and move into the attached lunar module, using it as a temporary lifeboat. This comparison highlights the physical constraints. The lunar module was built to support 2 men for a 2-day landing. Now it had to sustain 3 men for a 4-day voyage through deep space. To preserve what little power and water remained, the astronauts shut down almost every system. Inside the cabin, temperatures dropped toward freezing, placing a massive physical strain on the crew. Moving to the lunar module only purchased a few days of time inside a shelter that was gradually becoming uninhabitable. An invisible threat was also building. With 3 men breathing in a cabin designed for 2, carbon dioxide levels were rising toward toxic limits. They faced a hardware mismatch. The command module used square filters, but the lunar module sockets were circular. NASA engineers designed an adapter. Using instructions from Earth, the crew used manuals, plastic bags, and tape to bridge the gap. The improvised filter held. In extreme isolation, specialized hardware is often a liability. Survival depends on the intellectual flexibility to repurpose the tools that are already there. Even with breathable air, the ship was still moving away from Earth. A spacecraft traveling at thousands of miles per hour cannot simply reverse its direction in mid-flight. This flight path, the free return trajectory, was their only way home. The crew had to loop around the far side of the Moon, using its gravitational pull to slingshot the capsule back toward Earth. That maneuver committed them to a 4-day coast through the dark. They had to wait, trusting that their improvised life support and depleted batteries would last until re-entry. They lacked the fuel to overpower the mechanics of the solar system, so they used the physics of gravity to pull themselves back. Re-entering the atmosphere created a thick envelope of glowing plasma around the ship, cutting off all radio contact. For several minutes, mission control could only wait through the silence. Then, the parachutes deployed. Against the odds, the capsule was recovered in the Pacific Ocean, and ultimately, all 3 of the crew members returned home safely. On paper, Apollo 13 was a failure. It never achieved its primary goal of a lunar landing. However, reaching the Moon would have only validated the mission's machinery. Bringing this crew home validated the ground team's ability to find solutions for a ship that was never intended to survive.